DevOps is usually talked about from the backend's perspective. I'm about to change that with this video. So, welcome to Frontend DevOps, which is all about what DevOps is and what it means for the frontend development. I've been working with DevOps for my entire career as a frontend developer, and this is all of my knowledge packed into one video. Oh, and my dog wanted to be in this as well. But what is DevOps in a nutshell? Like if you haven't heard about it before. It's about creating better software faster. And it goes hand in hand with Agile. You know, Scrum and Kanban. But if you drill down even deeper, it's about creating a shorter development cycle. The time it takes you from thinking about the feature to that feature being out to your users. But what is the problem we're actually trying to solve here? I'm going to describe a company. You might know of a company like this, you might have worked at a company like this, but just think of your past experiences here. They have big and infrequent deployments, like once a month or rarer. That's horrible. Like there's a 1 month to a bug fix going out. You might do hot fixes, but then you have a month until you get feedback on a feature. You might be working on a feature that nobody wants for more than a month. And you also have deployment interference. This is where you're deploying a lot of features in your monthly release. At the same time, something breaks and you don't know which feature broke it. And at this company, you're probably doing manual deployments as well, but they are really error prone. You will forget something every time. And how fast can you do it? Under pressure. Like production just went down and you have to push out a fix. Can you guarantee that you're not causing more problems? And then we have the problem of long-living branches. You know, branches that exist for weeks or months even. Trying to bring them back into the main branch is going to cause merge hell. I was working at a company that had a branch going for the entire summer, upgrading to a new version of a framework, while developers were making features on the main branch at the same time. Bringing those two together was a hell. And production is someone else's problem. Like this is a mindset you will usually develop within these kinds of organizations. And I even seen places where a different company deploys to production than develops the application. That is starting to become a bit insane. You will have a lack of control and accountability. You don't longer care if the application works in production because it's a different company that takes care of that. That's really bad. So, what is the solution? Probably not a big surprise, but it's DevOps, the merger between the developer and the operations role. But this is a process, not a goal. You don't want to be the best DevOps engineer in the world, you want to make the best applications in the world. Just have that in mind. But it's the merger between development and operations, one that makes the application and one that gets it to production. But this is about merging them together inside the same person or the same team, or at least get them closer together. And DevOps is a fluid term and a moving target. This has changed a lot since I originally made this presentation a year ago. I had to redo a lot of elements, but DevOps is generally moving in the right direction, but it's still changing a lot. And a lot of companies are doing somewhat DevOps. That is where you're just doing some of the elements, but not all of them. And I think that's bad. So let's talk about that. What are the elements of DevOps? This is my experience, and my experience is of course more on the developer side, even if I have done a lot of the production side as well. But just know my bias there. The first element is continuous integration. This is about merging to master often. Don't have long-living branches. Have the maximum for 1 to 2 days or even less, like just hours. And you can do this with trunk-based development. I'm going to talk more about that later. Then we have continuous delivery. This is taking each of those merges to master or main and publish it directly to production on the merge, like after the pull request. This can be done with, for example, GitHub Actions. And here you can see a GitHub action if you're just wondering how they look. Then we have microservices. This is many small backends instead of one giant one, or a monolith as it's called. Just a side note, microservices are usually the best choice, but sometimes a monolith or one backend is the best if you have a really small application, because microservices add some complexity. But this can be taken to the front end as well with micro frontends. This is still a new and developing field, but here you can see an image of it. It's one application made in several frameworks stitched together in production. This is something we probably are going to do a lot of in the future, but the technology is not ready right now. But keep a lookout for this one. Then we have infrastructure as code. This is all about having your infrastructure or your service setup as configuration files so you can automate it. You know, instead of manually configuring a server, have a config file for it. Because this means you can tie it to a Git commit. So you know that your new feature that requires a certain setup of the server will be guaranteed as it's part of the pull request, part of the commit. And you can do this with, for example, Terraform, just throwing a name out there, but there's a lot of other choices. And then we have monitoring and logging. This is all about knowing instantly when you have production issues and be able to understand the issue after it happened based on those logs. And it can be done with, for example, application insights, but there's a lot of good choices out there. That was just one name. And then we have communication and collaboration. Have teams talk to each other. It's that simple. And you also need great documentation because your team will not be able to talk to everyone else all the time. Sometimes the documentation have to be a stand-in for developers being busy. And you need continuous feedback. That is all about using feedback from production to influence future development. Is a feature popular? Make more of it. Nobody likes something? Either fix it or remove it. And that gives us, in summary, continuous integration, merging to master often with short-lived branches, continuous delivery, publishing each of those merges directly to production, microservices, many small backends instead of one giant one, infrastructure as code, have your server configuration as config files and don't manually configure your servers, monitor and logging, know instantly when you have production issues and be able to act on that knowledge, communication and collaboration, talk to each other, that's simple, and continuous feedback, using information from the previous steps to influence future development. And that was the theoretical approach to DevOps. Now let's talk about the practical one. What is my dream implementation of DevOps for a front-end environment? This is my gold standard. This is what I aim for each time. But I know that the real world is different because different companies have different cultures and different setups. So I have to adapt it each time, but that is the point. The first element is hire people you trust and then give them the keys to the castle. This is the Netflix approach. Hire good people you trust and then give them access to everything so they can potentially take down the production environment if they want to. Because this means you can have autonomous teams that function more independently and can take key decisions on their own, which means they will work a lot faster. But you also need accountability. If the team does something good, they get credit. If they do something bad, they get consequences. I would highly suggest having trunk-based development. This is about having a main branch only that you have short-lived branches out from. You know, a feature branch that lives for less than 1 to 2 days, and then you merge it back in. And you should not push directly to main under any circumstance, except in the really early stage before you have a production environment. Because main is a stable branch. You should only have stable working code there because that is the production. And this means you will need a pull request gate. This is a pull request just enhanced, because normal pull requests are usually just checking spelling and so simple elements. Now it's really serious. Because everything that goes through the pull request is potentially shippable software. It goes directly to production once you click merge. That means you will need feature flags. This is like if you have a feature that requires several pull requests to be finished, then you hide it in production via a flag until it's ready. And you need a lot of checks. You know, automated testing, unit test, integration test, end-to-end test, visual regression testing, all of it. So you will have a higher degree of confidence that the code is good. Then you need deployment previews. This is really important because you will no longer have a test environment. So each branch or each pull request needs to be deployed to its own temporary environment. This is not provided by all cloud providers yet, so you need to shop around. This is really important so you can actually open it in the browser and see if it actually works. Because it goes directly to production once you click merge, so everyone has to be happy in the pull request. That includes the testers, the designers, the product owner, and no longer just the developers. Everyone has to check out the pull request now. And it has to be automatic, from the point you click merge to it going to production. You shouldn't be tempted to skip this. And you can do it with, for example, GitHub Actions. Okay, I just love GitHub Actions. I just wanted to throw that name out there. Now let's talk about automatic testing, where speed and reliability is king. The tests should be really fast and should not fail randomly. You should be confident that the test fails when something is wrong with your application. And I actually have time limits for myself there. Unit tests need to run in less than 30 seconds and end-to-end tests in less than 5 minutes. That might seem really low, but I think it's actually really high. You need the tests to run fast so you will not be tempted to skip them. And how can you achieve this? Well, for one, you should only test your application. Like if you have a on-click handler for a button, you shouldn't simulate the click event in a test. You should call the function directly because you shouldn't be testing the browser. That is something the Chrome team is doing already. You shouldn't test external systems. You should test your application. And test what's hard to make easy. Like, don't write a test that tests that some text is being displayed. I don't want 100% test coverage. But if you're implementing a binary tree search in the front end, that's a bit hard to make easy. So this will require a test. And I also highly suggest using Cypress for your end-to-end testing because it's significantly faster and more reliable than the alternatives. And you should also use stubbing. This is where you're no longer hitting your actual backend because your actual backend is unstable and slow. You should fake it in Cypress instead, so the tests will run so much faster and will not go down if the backend goes down. And then we have documentation. Keep it short and updated. This is really important because outdated documentation is worse than no documentation. If you have some outdated documentation, you should probably just delete it. And move it closer to the code. Like, stop having a separate Confluence page for all your technical documentation. Move it to the README file and the architecture.md file. The README file you probably already know of, but the architecture.md file is a new concept where you write about the architecture of the application in its own text file in the repo. And monitor production to influence future development. I haven't found a gold standard for this step yet. So this is something you have to look into yourself. And use Kanban. And don't try to use Scrum. Scrum might have some places still, but it invites you to deploy only once each sprint. And then you're back to monthly releases. So that's really bad. But Kanban loves continuous delivery as you're developing one feature at a time, and it's really natural to deploy each feature as they are completed. And do as much cloud and serverless as possible. Do infrastructure as code and infrastructure as a service because you're making applications, not servers. But know that clouds are flammable. That's a really weird thing to say, but there was a data center in France that recently burned down. And there was a popular game called Rust that lost all of their EU servers with all the data. All the players lost all the progress across all of their servers in the EU region. So still, even if you're doing cloud and serverless, remember backups. That's really important still to this day. And then we have the big one, trust. Trust your team, trust your boss, trust your customer, trust your user. Have everyone trust each other. This is really important because we want to break down the silos of the past where people didn't talk to each other. And we want to create a DevOps culture, and trust is the key element there. But remember that the code and the infrastructure is just a tool for solving problems. The focus should be on providing the most value for your users. Take a more pragmatic approach. And that was my dream setup. Now let's talk about the challenges of DevOps. The first one is that some of the benefits I talked about are not obvious instantly, like continuously deploying to production. That is going to be a really annoying thing until you get used to it, and then you will love it. And some of the elements here can be overwhelming, especially if you haven't done a lot of DevOps earlier. Trying to do everything at the same time will be challenging, so you might need to take some baby steps here. And then we have cultural inertia. This is about resistance to change. You might be working at a company that has a really broken development process, but it's a familiar broken development process. And it will be hard to convince some people to change. And this will not fix your toxic company or culture. That is something you have to address first. And this will be your biggest challenge. People generally don't want to change, even if it's for the better. But you have to stop and sharpen the axe. You have to stop your broken process, fix it, and then move on with a more sharpened axe. And then we have the big one. Operations DevOps. Because I've talked about DevOps now, and you might have a good idea of it, but there's one thing we haven't really landed on. Is DevOps a developer that knows operations? Or is it an operations engineer that knows development? Or is it a jack of all trades? We probably don't really agree on this, and a lot of companies have just said that DevOps equals the traditional operations role plus 10% development on top. They have just rebranded the operations role without adding in the benefits from DevOps. That's really bad. And this has accumulated in something that's called a DevOps team. You've probably heard of those. They've named the team after the process they're using. Like you wouldn't call a team the Scrum team or the Kanban team, but we're calling it the DevOps team. And that is just companies rebranding the operations role to make it seem like they are more modern than they are without taking benefit from the elements of DevOps. I think this is a really bad decision. And if this is something you are doing at your organization right now, then you should look into site reliability engineering instead. This is a term coined by some people at Google, and it's a specific implementation of DevOps. The one you're probably aiming for when you're having a DevOps team. Like they have a website and everything. But what is it? The focus now is on the operations side, where everyone is a software engineer. No longer will you have an operations team consisting of IT administrators. All of them should be software engineers, just as the development teams. And the key here is reliability, because this is meant for organizations that have large applications that can't really go down as much as continuously delivering new features can potentially do. And how they do this? They have a SLA agreement or service layer agreement of 99.9% or similar to that. That means that the application can be down for around 8 hours a year. If the application haven't been down that much yet, then the development team can push new features directly to production without asking for permission. If it's been down for more than that, then they can't. This is usually reset on a monthly basis. But that means there's no fighting over if they can deploy or not. It's just based on how much it has been down in the past. And it also mandates that developers spend a minimum of 5% of the time on operations tasks, and operations engineer a maximum of 50% on operations tasks. This will help them be updated on each other's fields. So then, in complete summary, we had the Stone Age, where we did yearly and monthly releases. It was horrible. Then we got DevOps with rapid releases all the time. And then we got site reliability engineering for larger applications, like Google Search and YouTube, where they added a sprinkle of reliability on top. But this means we have reached the end and you are ready to go implement this at your company or organization. Thank you for watching and thank you for listening to me talk about DevOps and what it means for front-end development. I hope you learned something new and exciting here, and if you have any feedback, comments, or need help of any kind, just leave a comment below. I would love to talk to you guys about this. This is really important to me, and thank you again for listening to me.